It's been really exciting. Like, there's a bunch of different product reasons why we're starting to integrate ZK into Arbitrum itself or into the Arbitrum protocol. This is, of course, as Off-Chain Labs, we're working with them. We can go into those product requirements or what we're trying to solve in a bit, but it's been amazing working with the Succinct team. It's been really a seamless integration experience. It's been unique too because we don't just have your typical EVM chain, right? We have multi-VM, so we run WASM, which supports then EVM as well as Rust and C, which is amazing because there's 20 million Rust and C developers, there's 20,000 Solidity developers. But so it's been a little bit different than your typical EVM implementation, but it's gone really, really smoothly. We've made good progress. We're proving Arbitrum blocks today, which is very exciting. We're in the process of optimizing it and building it into the protocol, and everything's just really gone very smoothly for that. Off-Chain Labs has always been technology neutral. Like we've written a bunch of papers on ZK, on AI, on fraud proofs. The history is kind of interesting, right? So the co-founders were two Princeton professors and then one of their students, and they wrote this paper before layer 2 concept even existed called Arbitrum, and it's an arbitration protocol that allowed you to basically execute something somewhere else and then prove it to another source, right? And this is actually like Arbitrum then launched later as the first layer 2 is perfectly applicable to blockchains. And this is really the technology that enabled the scalability of Ethereum through layer 2s to mass market. And for a long time, like zero knowledge proofs were not commercially viable, right? So ZK VMs, the first ZK VM really launched 2 years ago in 2023 by Risk Zero. And real-time proving first happened this year earlier by Succinct, or commercially viable real-time proving at least. And so it's still been a fairly new technology. But now it's finally like instead of having to write these very custom circuits for your ZK EVM, you can just run WASM on the ZK VM instead. And it's finally become commercially viable. Like it's cheap enough to actually start proving chains regularly. We aren't just like, we're not jumping on the ZK wagon just because it's a buzzword though, right? So we're really integrating it for product needs. So one of those is like you shouldn't just run a layer 2 with ZK and that's all, right? It's new cryptography. There will be bugs. So the way that we're implementing it is this multi-prover design. So you have ZK, TE proofs, and fraud proofs as a fallback. And this is what actually enables to make chains even more secure. So it's enhanced security on top of the fraud proofs that exist today. It also helps with faster settlement. If you use this multi-prover design, you can actually settle fast. If you just have ZK, I don't recommend it. It's really risky. Like, you should have some artificial delay to have the Security Council have actions.
And expensive, right?
And expensive. So there's different ways to implement, but we really came from a product needs point of view. Like, what does this solve? And we waited till that moment that it made sense to actually do it. And now that it is finally commercially viable, we're building this out. It should be coming soon. The engineers would not let me say when, but very soon, in the matter of months. The end user should notice nothing, right? This is one of those things of like, I think for blockchain in general, if people know they're using blockchain, we probably messed up. Like you really shouldn't. How often do you think about HTTPS? Or actually, we might know the name HTTPS, but no one knows how it works. Most people don't. You don't know about what server or cloud your website's running in. So for the end user, it'll just mean you can still make transactions on Arbitrum chains. For the chain operator itself, like they can rest assured that their funds are safer. You would be harder to hack because you have to find zero-day exploits in the ZK verifier or implementation, the TE, and the most battle-tested proving mechanism, which is our current multi-round bold. And so it'll just be there, right? You can get faster settlement now. You can have lower bond costs because you don't go through multiple rounds in the beginning. And Honestly, like that's the design goal. Is you won't notice. You might get privacy in a private chain, you might not, but hopefully for the end user, nothing changes. ZK's moved really fast, right? Turns out billions of dollars is a very good research bounty for academic researchers. Math doesn't normally move this fast, right? But blockchain is the perfect incentivization method for these cryptographic primitives. So we really don't like. I've been talking to the different ZK VM teams of like, there's no sort of diminishing point that we see right now where it won't keep dropping around 10x or 5x per year in cost. It's just a matter of like more research, more development. Right now, ZK is still quite expensive for if you want like a gigagas chain and for real PMF like chains like Robinhood or Converge by BlackRock. I'm not actually talking to their implementations, but I'm saying like if you have real users that push a lot of transaction throughput, this may or may not be the right choice. That's why we have this your chain, your rules. You can change the configuration of that multi-prover to fit your needs and keep the transaction fees low. But there is a future of some years from now where every single chain will be ZK, or most chains. There will be some that won't, like games, for example, might not want to pay for it.
Yeah.
And it'll get faster and cheaper to keep proving over time. Let's say you're a bank or a RWA chain that doesn't have a lot of transaction throughput or just needs to optimize for very fast settlement, right? That's a use case where you might want to ZK prove everything. For the hybrid or optimistic settings, like let's say you're a game or a price sensitive application like payments, where you don't have to settle very, very fast, things happen on that chain. There's a bunch of different configurations where you like the users, the builders need to be able to choose the right configuration. People are price sensitive. A lot of chains for different stacks are losing a lot of money because it's very expensive to run those chains. So we'll offer those options where you can kind of walk then run. You can start on Arbitrum 1, move to your own chain, and over time it's variable cost rather than fixed cost, so you can scale up operations as you get more throughput or PMF. Yeah, so at this point we are proving Arbitrum blocks. It's again we're proving WASM, which is unique. It's been really exciting. I like basically we've de-risked the process to the point that we know that we can prove Arbitrum. We know we can do it cost effectively, and we see no obstacle where we can build out these different configurations. So it's been really nice working with them. Honestly, they're very qualified, and I'm excited for this to come as an option for chains.